Well, hello friends, and welcome back to DevTools Hacking. Today we're going to look at trying to make at least the start of some syntax highlighting for C++. And the first pass of this, we're not going to integrate with any kind of compiler or parser or anything like that, but my plan is to just lex the language and then use that to create a basic syntax highlighting functionality. So what that means is that we're gonna take CPP or C++ and turn it into a stream of tokens, and then we will see if we can highlight based on that stream of tokens. So this means that we're gonna figure out like what's a parenthesis, what's a plus sign, what's a string, what's a comment, stuff like that. But there's not going to be anything like statements or loops or anything like that that we'll identify, because that would be parsing, and we're going to stick to lexing only. And I think we're going to write it by hand, and then we're just going to see what we can come up with. I've never tried to lex or parse or anything like that C++ before, and I'm not very experienced with language stuff in general. I've used languages, but I've never tried to write code that comprehends them. So I'll probably make some weird mistakes and stuff, but we'll just see what we can come up with. So let's start by making a file for this. We'll call it what am I thinking? Let's just make a file for it. CPP, we'll call it CPP lexer. What am I trying to do here? Okay, and we can just put that here. CPP hexer, lexer. Okay, and so let's see how we approach this. And I guess this is gonna take some time here to like build this thing, because I've never made one. So we're definitely going from first principles here. So let's just give it some silly interface, and we can have it give you a CPP token. And we'll have a type, enum class type, and let's say first one is invalid. And then we can have, like, I don't know, some things: left paren, right paren, left curly. These type of things. We're gonna need a lot more of them, but let's just put some string, double quoted string, single quoted string. I mean, it's really just a character, but you know what I mean. And then we'll do comment. Okay, so we'll try to lex out these token types to begin with. So we're gonna have an API that gives you a vector of tokens, and the input to the lexer will be a string view. And of course we're gonna need an ack vector and CPP token. Oops. Lex. Okay. I'll call it M input. I think that's good enough for a start. So then how do we actually test this out? Well, we're gonna just, in Hack Studio main, we are just going to, let's make this easy for ourselves and make it run on startup right away. So I'll just say cpp lexer, and we'll give it a, we'll just load up a file here. Construct with home non little cpp, or no, it's called main cpp. That's our little test file. File dot contents is file read all. Assert that it's not null, and then contents string is, we'll just grab it into a string here so we can pass it to the lexer. And then auto tokens is lexer.lex. cpp lexer, okay. And then what we'll do next is for auto token and tokens, debug token dot type, or let's say toString. Maybe token type name. What do we even call this? Let's say toString, whatever. And of course, there's no such thing, right? So cpp lexer, let's add a toString here. Just something very simple. Switch mtype, type mtype, type invalid. Then we need all these types. Okay, oh, that's so weird. All right. I'm doing a little bit of rote editing here. It's not enough to write a regex. Oh crap, that's not what I wanted at all. Oh shit, forgot to say case. All right, there we go. And we just have to actually print something out, so, or return something. Oh god, this is such boring editing. This is actually such an annoying way of doing this, and I'm going to do it differently right away instead. Let's use a macro. For each token type. I'll say x invalid. Yeah, and then we'll do all of these like that. Okay, something like that, and then here we would do enum class type for each token type. Wait, why am I totally zoning out here? That's the way I normally do this. I have this in syscall. We enumerate the syscalls, and oh, right. That's not how we do that. token. Define token, just X. Like that. Okay. Okay, it's been a while since I was using macros to do stuff. This is how I would normally do this. So let's do it this way. Okay, for each token type. Class type for each token type. Okay, like that. Oh, messed that one up. All right, there we go. Finally. Okay, and then here we can do for each token type. So now we can just undef token. Let's do that up here. And then now we want to do case type x colon return x. Something like that. I put these on a single line actually. Duplicate case value left paren. Oh, right, because I have to delete all of these. Okay, this using the C preprocessor in this way is so awkward, but it's also really powerful. But it's freaking weird. All right, so now we can just add tokens here, and they get stringified correctly and added to the enum and everything. But that was indeed very tedious to write. Okay. Yeah, whatever. So cpp lex. Okay, so let's write this thing. And and we're gonna need to know where we are in this thing. So let's just have an index. Okay. And then vector token cpp lexer lex. They're called cpp tokens. All right, so I guess we just go like this. Or wait, what was the thing called? Mindex, right. It's called length. All right. ch is minput at mindex. Now, what we want to do is let's put this in a helper function. It's called peek. And let's put it here. Char cpp lexer peek. Input index. And if we are at the end, then we'll return 0 here. So this will allow us to always call peek. Char peek const. It just looks ahead. And then we should also have a consume that actually advances the pointer, which will be similar, but just consume and we should assert that we are still inside the string, and then we'll return what we would peek, but we will advance the index afterwards. Okay. Now, we have the next character, so let's just take a look at what it is. Well, what were the types that we wanted to find? I guess left paren, that's a pretty easy one. So we can do, let's see, vector CPP tokens, return tokens. Okay. And then here we can do if ch is this tokens, append, and maybe we'll have something like this, make token. How do we make one easily? We should have a helper for this, but CVP token type left paren. Okay, and then we'll just make that little helper here, make token, CVP token type, token dot, and type is type. Okay, we'll be expanding this eventually for things that are more complicated tokens. Like that, and continue, right? Straightforward, so then we can do a bunch of these. Wow, my computer fan is going crazy. Oh, QCreator is very, very busy. And if I close the header file there, it's no longer busy. Maybe its lexer was going crazy, who knows? So there's definitely like snazzier ways of doing this, but I'm just going to approach it from this angle right now, and we'll see what we can come up with. Let's do bracket, zip. This is really wordy. How about we do emit, and then make a little function here that just adds it to the tokens type, and then this will just be tokens dot append make token type. Okay, that way we can just write emit instead. It's slightly less noisy. And these should probably be a right curly and a right bracket. Okay, so what other things do we have? Done those, and then let's do double quoted, single quoted, and comment. And then I guess we should also do like a number and identifier, because we're going to need those. All right, so if ch is I mean, we won't be able to know if something is a keyword or an or what, or like a variable name or something. And I don't remember if I'm using an overloaded term here by saying identifier. Oops. I should know what a C++ identifier is, but it's a name used to identify a variable, function, class, module, or any other user-defined item. Right. So that's the wrong thing to call this. Let's call it name. Or how about a name? Name. Yeah. Our name is terrible too. Okay, frick it. Let's go with identifier. And then identifier in the Lexing context could also be a keyword. But maybe we can figure out if things are keywords, actually. I guess we could figure out if things are keywords. Because why couldn't we? So let's do it that way. Okie dokie. So if something starts with what were we looking for? Let's look for comments. So if ch is slash and peak1 is also slash. Oh, I want to have peak be able to look ahead, actually. So let's give that an offset, by default 0. And then we'll say that we are checking index plus offset. This means that we can look further ahead. So in this case, this means that we should, everything up till the next new line character is a comment. So emit cpp token type comment. And I guess that's okay for now. Oh, can we see what this file looks like? Because I don't remember. Little cat main. Okay, so this is the thing that we are lexing right now. Maybe we can add a comment to it. This is a comment. Okay, so we want to do this one. If we find this one, then if we're at the start of a line, then that means that, or let's say if we find this one, it's a preprocessor. The rest of the line is for the preprocessor, and we should ignore. So let's see. Token preprocessor statement. And then we should actually also go to the end of the line. So let's see, consume while peak is and peak is not new line. Or actually we can do it this way. If consume is new line, then break. Yeah, then we'll advance to the new line and then end up after the new line. Okay, and let's do the same for the preprocessor thing. So preprocessor statement, continue. Okay. And then I should do the C style comment. So this means that we're starting a regular old style comment, and then we should, while peak, if peak is this and peak 1 is this. Here first we have to consume twice. And same thing here, we gotta consume twice. I mean, actually, we don't have to consume twice here. Let's keep it simple. But here, let's consume twice to make sure that we get past this one. And then, there we go. And then, what else did we have? Double quoted string, we definitely have those. You can see, well, this one is going to be identifier, or rather keyword. This one is going to be white space. Oh, white space. Totally forgot about white space. So let's say if is space ch while peak consume continue. Okay, so emit CPP. Oh, we can't even not emit anything for the white space because we don't need that. It doesn't tell us anything. Of course, we're going to want these things to have offsets so that we know which part of the file is what. So, because we're not trying to compile it now, we're trying to highlight. So we're going to need more than just, I mean, these are single character things, so that's fine. But in this case, for instance, we need to know how much was white space. So when we emit, we want to, so here maybe we'll say begin token, commit token. And then we'll have a start of token start index. Auto begin token. It's going to be a little function that captures the token start index by reference, and it will just set it to wherever we are right now. And then cannot be implicitly captured. Well, my bad. Okay, let's just do it that way. And then commit token is going to say I'm going to append token, make token. Maybe make token was a silly idea here, because in this case we can just do it this way here. And here we want to add a bit more stuff to it. So we want the type. Commit token is going to give us the type, but then we also want to have a substring or a string view on the token so that we can get the characters later on. So this will be string view of m input dot characters without null termination plus token start index, and the length will be m index minus token start index. Okay, let's just say here that that's the string view. All right. So then when we say commit token, then we have to say CPP token type white space. And there we go. Okay. Right, and then when we do the regular emit, where did that even go? Oh, it doesn't exist. Emit, we are going to instead say, or emit, we can call it that. Emit is here. All right. Emit, let's rename it to emit token. Emit simple token, maybe? No, emit token is fine, but it's gonna use the view is gonna be a string view of m input characters without null termination plus m index, and it's one character. Okay, now this one is used for single character tokens, and this is for longer stuff. So here we have to not emit token, but we rather instead begin token, and then commit token. And same thing here, begin token, commit token, begin token. the new line should probably not be a member of the comment. So a peek and peek is not an consume. Yeah, let's do it that way instead. Still figuring this out, as you can see, but this feels vaguely reasonable. All right, and then what else can we do? We're still not doing anything about this. We're going to need comma and asterisk. So let's add those. Let's just put them somewhere. It doesn't matter that much. Comma, asterisk, semicolon. Okay. Blah, blah, blah. I mean, those are all simple, right? They're just more of these. It's like comma, asterisk, semicolon, comma. This could definitely be written in much more packed way, like just a big table. And we'll probably do that later, but right now this is okay. So now we just need to do the keywords, identifiers, and numbers. Then we and strings, strings, right? So maybe let's start with string. So if we encounter a double quote, then we'll begin token, and then while peek and peek is not a double quote, we'll consume. And then we'll commit token, CPP token type, double quoted string. Continue. And I guess we can do the same for single quote. Obviously, this is not going to be perfect, so I'm just trying to build something that would kind of work, sort of, and we can see if we can work from that, because you can't start out perfect, obviously. So I guess those are those, and then let's do maybe numbers next. So ch is ch 9, then begin token. While peek and peek. Why didn't I just say is digit actually? Consume, and then commit token. CPP token type number. All right. Continue, and then we need keyword and identifier. And those are going to start out the same, because we'll just figure out if something starts with a character. So if is alpha ch, or let's see, is I mean, what can they start with? Alpha ch or ch is this, and maybe there's some more characters that can start with, but those are the ones that come to mind right now. Is valid first character identifier. Begin token. While peek and is valid character anywhere in identifier. Or no, valid non-first character of identifier. Peek. Consume. No, we're not going to commit it. Okay, hold on. This is the tricky part. So static bool return is alpha ch or ch is underscore. I would not first. So here we'll say is alpha or numeric, and we'll also allow some other cool character like the $sign, which is super duper cool. I think you can't have them first. Maybe you can. Damn. All right, maybe I'm wrong about that. Let's see, int x. Oh shit, you totally can. Okay, but you can't have a number at the start. So I guess we can say if is valid first character, or oops, is digit ch. That's neat. Okay. So now we want to look at our token and see if it's a keyword or an identifier. So how do we get what we have so far? That would be this. Token view is this. Okay, and then we'll say if token view, or let's see, how do we figure out keyword? Let's make it easy. We'll just say is keyword token. Then commit token cpp token type keyword else identifier. Okay, then we'll just need to implement a static bool is keyword const string view const string. Okay, and then here we're just going to be really lazy right now, so I'm just going to put the ones that we already have. String is int. Or if it is char, or if it is return. Okay, nice. So can we run this? Will this run? It almost compiled. What did not work? Lexer 42. Oh, here. Right, so let's assert not reached if we get to the bottom of toString. And let's see what comes out. So now when we start Hack Studio, we should get a printout of the token stream, if we're lucky. Yeah. We didn't even manage to load the file. Okay. Home and on little main CPP, because I'm not calling open. Success, assert success. Dang it. Okay. Forgot to open the file. That usually helps. Okay, so we crash because we run out of physical pages, run out of memory in the kernel. It's probably not a good sign. What are we doing wrong? I guess we can start by returning here, by the way. So I guess we're trying to lex, but what is the thing that goes wrong? Is it that we don't advance the pointer in all cases? Emit token. Oh, when we emit, then we don't advance. So maybe we should bake that in. And index plus plus. Because emit is like our quick, simple, fast path for single character tokens. And we still die. Okay. Let's see. Lexing. And then let's just dump out what we are lexing at the moment. Debug was not declared in the scope. Well, golly gee. Oh, seems like we're stuck on a double quote. What did we screw up? So we begin token, and then as long as we don't find the double quote. Oh. So that means that we just get stuck there. Well, peak. Consume. If, let's see. If consume is double quote break. Oh, oops. Copy paste mistakes. Not the best mistakes. And I forgot to also consume here, actually. Because we got to consume after we start, after we encounter the first single quote, then we have to consume everything past it until we get a new single quote. Okay, there we go. So this is our output. Oh, let's see how this matches up with our actual program. Little main. So we have a preprocessor statement followed by some white space, followed by a keyword, then white space, then an identifier, then a left paren, another keyword, a comma, white space, keyword asterisk asterisk, right paren. Where am I? Right paren, white space, left curly. Yay! Here's a comment, followed by white space, left paren, right here. This is looking very good. Yes. So I think we should unhandled token character, unimplemented token character. Serve not reached. Just so that we fail here and we can like figure out what thing we need to implement when we test this on something. Okay, so what was unimplemented? Oh shit. Wait, why? Oh, the preprocessor thing. But we were supposed to consume that whole thing. Wait, what? Okay, so we did, this was the preprocessor. We went all the way to the new line. Here comes the new line, and then comes an I. And then we can't deal with the lowercase I. Why not? Oh shit, because we don't continue here. Okay, there we go. Okay, so there we have our beautiful token stream. Cool, 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 cool. So I guess now the interesting part becomes how do we make this show up in the text editor? So let's see. Let's commit this first so that we have something that we're working with. DevTools, Hack Studio, CPP, Lexer. If we won't commit the main change. I mean, not this main change, like because it will make Hack Studio exit at startup. So we're just going to commit this so that we have it. Hack Studio. Start building a simple C++ lexer. A C++ lexer to help syntax. Okay. This is obviously, we're going to need a bigger list of keywords eventually, but we're good with these for now because we just want this particular file to work. And then let's see, text editor. So what we want to do is we want to show some different, let's say that we want to do the keywords in a different color, for instance, and maybe we want to be able to have bold or not bold. So essentially what we want is per character attributes like font, color, because we still want to be a fixed width editor, right? A monospace editor. So we just want to be able to style individual characters. And then we want to take the information from the lexer and use that to set the attributes on everything. Does that make sense? Okay, so let's see how we do this. So right now, the text editor internally is just a vector of line objects. We have the vector of line here, and each line is a vector of characters. So here's where the text of each line is contained. And then for when we do, if we have line wrapping turned on, or like, you know, where it wraps at the end of the screen instead of continuing, so you have to scroll. This is what that's for. So this is the, like, where are the lines visually broken because of the size constraint of a line wrapping text editor. So this is only used if line wrapping is enabled, just so we know where the breaks are. So I guess what we could do here is something like attributes. Let's say. And then we'll do a struct attribute. And that will be a const font. By default null footer, in which case it will just use the default font of the editor, and then it will also be a color. Does that make sense? In fact, we could, I mean, I'll put the font here now, but I think we're just going to care about the color at the moment. So we're just going to care about the color, yeah. Okay, so then how do we manipulate mtext? Probably in many places, which is going to be really tedious. Text clear. set text. So like anywhere that we are manipulating m text, we really want to do the same with the attributes. So maybe it would be easier to just make them make this be a character and attribute. But then we are using it in so many places. I mean, the attributes are going to come from the outside. So how do we do that? So I guess one way that we could do this is that when the text changes in the editor, in the text editor widget, then we can invoke some kind of a hook, and then in that hook you can go and update the attributes for each line, and then you can set an attribute on every character in the document, and then when we paint, we'll see if there is an attribute, then we'll respect it, otherwise we'll do nothing. Let's try that approach. This is kind of a straightforward approach. So paint event. Text editor painting is a little chunky. There's a lot going on. 99% of the complexity here is selection, because selection is a little bit it's a little bit tricky to paint the selection with word wrapping or line wrapping enabled. So I know that this could be written in like half the amount of code. I just didn't sit down to simplify it. But when we draw text here, then right now we're doing a single call to draw text, but maybe what we should be doing is should be going character by character, or really like span by span would be the ideal. So maybe attribute shouldn't be attribute, it should be attribute spans. And then this will contain something like attribute span, and an attribute span will be a int start int length, because that will translate quite nicely from the data that we get from the lexer. Yeah, and then let's see, so void set attribute span for line index const vector attribute span. Does this make sense? Let's try it. And lines, line index -1, because it's 1 based. I hope. Actually, it's 0 based now that I think about it. So this will assert if the number is bad. So spans. I guess we could even move this actually. Or wait, that doesn't really achieve anything. So there's nothing here that benefits from being moved. So cool. So then what the frick do we do in text box? Or maybe it should have just been called spans. Set spans. Yeah, I think I like that better. Span. So each line has a set of spans on it. And then the spans come from the outside. Okay. Text editor, paint event. So then when we want to draw text, where is the regular straight up draw text? The selection stuff. Here's the regular straight up draw text. So here we are just gonna, this is gonna be slightly complicated, I guess. Because we are getting called here with line wrapped things. Are freaking line wrapping, making this harder. But it's such a nice feature. I should turn line wrapping on in the Hack Studio, by the way. So, okay, so we want to respect the spans here. Okay, I'm getting stuck in my head, so let me go and work on the other side of this for a moment. In CPP Lexer, we have in Hack Studio where we open a file, so let's not do that anymore. And if, okay, and then when we open a file, we get here, and then we could say that if file name ends with .cpp, it's going to be very fancy here, then CPP Lexer. We have the file contents here actually. Contents. Okay. And then we're just gonna do this one time right now. We're not gonna like care if you edit, then it will fall apart. So, but we're just gonna want one pass to work. So I guess it would be really, really helpful if the tokens would have the line number and the starting column and the length instead of just a string view. String view is actually not that useful to us. We can leave it there, but line number, column, and a length. Line, column, and length. Okay. And how do we know what line we're on? We're just going to keep track of it. So let's do this one-based. I'm tired of zero-based lines. And I got to convert the code wholesale to that. Column is 0. But at the same time, I don't want to have, oh, this is how it perpetuates itself. I don't want to deal with it right now, so I'm just going to do it zero base here too. And then I can go, I mean, I have to go and do like a pass over the whole code and change everything to be one based in one go. I can't like do one class differently than the others because that's going to be so confusing. I'm going to have to set aside some time to do this. Okay. So actually, let's put these far up here so that we can access them from these guys. And line is line index, token.m, column is column index, and token.m length is 1. And for these, So it starts on this line. So it's not actually not even enough that we know we need start line and start column. And the end line and end column. And the length is kind of arbitrary, actually. Okay, so start line and start column. The single character one is easy, right? Because it's just like that. But here, I guess we should have some kind of an object for this. So let's say struct cpp position. So let's call it source position, maybe. Line 0, column 0. Okay. Okay. CPP position is better, because then you can tell that it belongs with these other things here. Let's have some default values that would break everything if you accidentally use them. Okay, start is equal to line index, column index. So here, token start index, we should probably, it should be like token start position. Okay. And then here, we will set it to be line index, comma, column index. Okay. And then token m start is going to be token start position, and token end is going to be current position. All right, that's good. Now these are called position instead. And we don't need the frickin' string view anyway. We don't care about the string view. Let's get rid of it, actually. Okay. So type start and end. Very good. And then we have something here that's wrong. The token view, right. This is just to identify the keyword versus identifier. So here we need to token start position to token start index. Yeah, that's actually, that's still useful. So let's also track that. Token start index is m index. Okay, great. Is it still built? Yeah. All right, so then we have the tokens. And actually, let me dump these out in the new format down here, because I'm curious what they look like. ToString, and let's put some more stuff in there. Or actually, no, let's not. But, token m start dot line. M start column to token and end line and colon token and end column. Oh man, is this going to make sense? We'll see. So now when I open a CPP file in Hack Studio, then we should get a printout. of the tokens and where they are, and this absolutely did not succeed. Why did it not succeed? Let's see, CPP lexer. Why are these all zeros? I wonder. When we create the tokens, we append, oh, right, because we never actually update these things. So I guess, let's say if ch is a new line, then, oh well, wait, what's the right thing to do here? I mean, we're at 0, 0 here, so if we get to the new line, where is the new line? See, I want to do something before I continue, so shit, I'm gonna do a go to next thing here. This is so gross. Actually, I don't have to do that. I can just use a for loop instead. What is the thing I want to do? I want to advance the column thing. But how do I look at it? CH is the one that we were processing, and CH equal to new line. So increase the line index, and column index is 0. Otherwise, increase the column index. Expression not assignable. Excuse me, princess. Variable C is uninitialized when used here. Well, it's not really true. Oh, it actually was. Shit. Sorry, my bad. Okay. This is so filthy, by the way. Jeez. Okay, so what did we produce now? Okay, looky here. Preprocessor statement. That absolutely looks like crap. These all look terrible. What the heck? This is in no way right. Okay. Right. This can't work this way. It's totally busted. Okay. It was a nice idea, Andreas, but that's not going to work. We have to when we consume, because everything goes through consume, so we can make use of that. And we'll take line index and turn it into m line index. And oh, crap. And the same thing with column index. Okay, and then we have, we'll just put it right here. In fact, maybe this should just be a CPP position, actually. Starting out at 0, 0. Okay. Position. See, this is getting tidier the more we refactor. And there we go. All right, and then what we want to do is update that, and we'll do that in consume. So char ch is m input at m index plus plus. If ch is new line, position dot line plus plus, column is 0. Cool. else m position dot column plus plus. Oh, dang. Okay, so the preprocessor statement goes from, oh wait, hold on. White space goes from 7. So these are 0-based line numbers now, just to remember. It's really only in the UI that the line numbers are 1-based. I think maybe that's okay. Ugh. It's like a stupid long-running internal struggle. Like, should I make the line numbers 1-based in the code, or should they be 1-based in the UI and 0-based in the code? I just keep going back and forth. I don't know what the hell. Anyways, these things look totally reasonable now, which is awesome. So these are actually what we should be giving to the text editor. I mean, these are essentially our spans, more or less. And yeah, this is the span information. It's just that we want to put a color here instead of a token type. So let's see, let's make spans out of these. Token. So let's make a span. How do we make this one per line? Let's see. G text editor span. Spans. Oh, it's a protected member. Shit, we gotta upgrade this guy to public. I didn't realize we were in the protected space down here. Okay, so now it's public. We can use it, and then we'll say mspans resize to the G text editor line count. Okay. Because then we can do G text editor set spans. We do them per line. Okay, well, let's have a different API where we just give it a big chunk of spans. So how would that work ideally? We have gText position, which is a line and column. It's very similar to the CPP position we just made. Is that thing 1-based? It doesn't appear to be. So I guess the span could have a gText position start, gText position end, font and color. We'll do that, and we'll take the spans like that. Okay, and spans. We can move them out of the line struct and just put them here at the bottom. And then each line doesn't have to care about spans. We'll look that up separately. All right. Now let's produce these. So then each span is just, we're just going to produce one span per token. Span, or gText editor span. And start. gText position token mstart line token mstart and column. That's what I wanted to do. Okay, we can actually write this like this. And okay, span color is going to be, let's say, color for CPP token type. And type. And span font. We'll just go with null footer for all the fonts right now. And then spans append span. And then when we're done with that, we'll do gtext editor set spans spans. All right, and then color for token type. We'll just put up here for now. Static color to CVP token type. Switch type. CVP token type keyword. And for those, let's do some cool one like return color dark. Do we have brown? What's yellow? What would that actually look like? It's very bright yellow. Don't we have a darker yellow? I want it to have a darker yellow. I guess we can just say it manually, actually. Color 128.128.0. Okay. And maybe for string, we can do some darkish red. It's kind of neat. Double quoted. Can do the same for double and single. And then for the rest, actually, let's just say for the rest, return color black. For now, maybe it would be cool to have numbers in a different color. What does Vim do? Oh, wait, what am I trying to do? So purplish, same as the string actually. Oh, identifiers are white here. That's kind of interesting. I would like to have the identifiers be slightly different. Let's make them blue. Dark blue. Going into important details here. Okay. Yeah, actually, numbers should be a darkish purple. Alright. That's enough fooling around. So will this run? Obviously, it's not going to do anything with span information yet, but we can see if we can at least run the code that produces it, and everything still does not crash. Okay, we're good. Great. Okay, I got myself a new cup of tea here, so let's engage with the rest of this problem. So we have all of the tokens, and we've turned them into spans, and now we want to make sure that the gtext editor paints the spans correctly. Now, let's just start by doing this in a naive way. So the way that we paint right now is that everything goes through a unified code path. This is in gtext editor paint event. So what we do is we iterate through the the physical lines of text in the text file. I mean, there's like physical lines and visual lines. And the visual lines is just if you're doing line wrapping, then your visual lines might be different than your physical lines. But what we do is we iterate from, these are physical lines. So we iterate from the first visible physical line to the last visible physical line, inclusive. And for each physical line, we will iterate its visual lines by calling for each visual line. And then here is where we draw the text. We saw this before, but basically we make a single call to draw text, where we pass in the visual line rect and the visual line text, the whole text of the visual line, and the text alignment and the color. So I'm thinking what we could do here is we can make a little naive solution where if we have spans, then we will iterate over this and do character by character drawing instead. And for each character, we'll look up the span for it. So let's see. mSpans is empty. Or if it is empty, we'll do it this way actually. Fast path for rich text. I guess that's essentially what this is, right? Because spans will allow you to do richer text, at least non-rich text for non-rich plain text. Should we call it poor text? What is that in poor taste? Poor text. We can call it poor text. That's kind of cute. But actually, maybe that's plain text and this is poor text because we still don't allow you to set a different font size or use, yeah, you still can't use different font sizes, but you can still use different colors and different, you can have like bold or italic or whatever. So maybe that should be called poor text or middle class text. I don't know what the hell I'm trying to accomplish by by saying these things. Let's just iterate over the thing character by character. So Sergey is going to be sad if he's watching this because GText Editor needs an overhaul to support UTF-8, but that's not why I'm here right now. So I'm not going to do this in the UTF-8 way. Let's see. Line text length. Okay, and then we have, this is where we're going to start our characters. So I wonder if, I'm kind of thinking like, what if there was a draw text API that allowed you to pass in the text, but also like an array of colors for each character, but that's goofy. Okay, let's not do that. So rect character rect. I'll call it glyph rect is this one's location, and then the font glyph width and font glyph height. Did this not work? Too few arguments. Oh, I have to specify a character. Well, it's fixed with, so we'll just do that. Do we have this information somewhere? No? Okay, so this is just making a rectangle that we're going to use for individual glyphs, and then we're just going to keep moving that rectangle to the right as we print, as we draw each character. So first thing is, let's just see that we can draw this stuff at all this way. Draw text, do we have draw character? Draw glyph? Can we call draw glyph directly? It is public. Okay, so how about we just call the draw glyph with glyph rect location and the visual line text I, and we'll do it in red because that way we can recognize that this code path is happening. And then after each thing, we want to just glyph rect move by. I guess we should store this here. Glyph advance. Let's just call it the advance. glyph width of the space glyph plus font glyph spacing. Advance and no Y movement. Okay. Let's see if this works at all. Because if we can draw the lines character by character, then it's just a matter of figuring out which color to use for each character, and then we will have a very inefficient but functional painting code for our span data. So let's see how this goes. Plop, and it's all red. And it's a little off, actually. It's not exactly in the right location. That's a bit annoying. Why is it like that? Oh, and the text alignment. We're not passing the text alignment. Shit. Okay, well that's okay. We can just not use drawglyph then. We'll just use straight up draw text. I'm not going to pass the glyph rect and the text, which we'll have to do as a substring view, I length 1. What comes after? Text alignment, M text alignment. Okay. Oops. I think if we do this, it should end up in the right place. And then, as you notice, like when we select the text, then it will not be painted with any. It will be taking a different code path for painting selected text, and I think that's okay because we want the selection to stand out anyway. But I don't know. Maybe we'll revisit that. But yeah. Now, oh, it's still popping out of place. Damn it! Why is it doing that? I guess because I'm using the glyph height here for the glyph rect, and we should really be using the line height, I think, because the text editor widget has the glyph height plus the line spacing as the line height. So there's like a configurable amount of line spacing, which is just how the Y distance between each line. So there's a little bit of gap in between the lines just to make it look better. And that's the line spacing. Okay, so finally we can it does not move when I do that. Very, very cool. Okay, so now all we need to do is get the right color from the span info. So what will be the extremely naive way of doing that? Maybe we'll rename this to character rect. Okay, the extremely naive way of doing that. Wait, hold on. My keyboard is all goofy. So, oh, the stand was not up. That's why everything was all slanted to the side. Keyboard stand was down. So let's just find the span and grab the color from there. So color, we'll just naively walk all the spans for auto spans and spans. Sorry. Okay. If span dot guess we can do a span contains, and then we want to find out if it contains the current position. So gtext editor, gtext position. What is our current position actually? I guess it's the current physical line, which is the line index, and the column is the I plus the visual line, start of visual line right here. Okay, so say start of zero line. What's that? And physical line is line index. Okay. G text position. Span contains G text position. Physical line. Physical column. If it doesn't contain, then we'll continue. But if it does, color is span color break. Okay, now we just have to implement span contains. Span, right? Then this thing needs a bool contains G text position. And I feel like we have some more things with G text range. Looky here. So really we could have text ranges on the spans and instead of G text positions. But alas, G text range still does not have a contains function. So let's just bang out a contains function down here. So if position line, or how can we compare these? Less than. I guess we'll just say if position line is this, start line and position line is less than or equal to. Hold on. This kind of stuff always trips me up. Position is greater than start line, or position line is start line if we're on the same line, and position column is greater than or equal to start column. Okay, so we can reverse that and say return false. And then if position and line has to be less than end line or equal to end line, and position column is less than or equal to end column. And we'll reverse that and return false, otherwise return true. It's probably a much tidier way of saying that, but it was what my brain wanted to write. So come on and build. So this is obviously a very inefficient way of painting, because it means that not only do we go character by character here with individual calls to draw text, but we also walk all the spans for every character. So obviously this is not going to be the final algorithm, although it might be the last one I do today. And shit, I feel like I'm seeing color, but it's not. It's too, my screen isn't helping me, but am I seeing color here? Wow, I wish I actually I can't tell. I have to tweak the colors a bit, I think. Where did I do these? Here. Okay, let me just use really noticeable colors instead of these things that look almost like magenta and blue. So dark blue number can be blue. All right. Oh man, look at that stuff. So obviously this color is stupid. So we'll use dark green instead for the keywords so we can see what they say. Yellow on white. I don't know what I was thinking. Okay. So here it's looking good, except this one is a little off because the I is black. And also, let's do the preprocessor tokens in a different one, and comments should be different as well. So, case CVP token comment dark gray, maybe mid gray. Preprocessor statement dark. What did I want that to be even? What do we have here? Magenta. We were already using that. But strings could be red. That would be cool. I mean, obviously you might want these to be configurable, but oops, I'm just playing around here. Okay, so it's looking pretty cool, except we are off here a little bit. The keywords, they don't always do the right thing. And identifiers, dark blue, let's make them regular blue so that we can see them better. But why are the keywords like that? So when we parse the keyword, let's see, is valid first character of identifier. Then we begin the token, meaning that it starts right there. And then we consume as long as, I mean, presumably we were able to identify that it was a keyword, so we must have known that it was int in that case. So we started it at the right position. And we can actually see it right here. So that's the include, that's white space, and here's the keyword starting at line 2, index 0 through 3. But why does it come out wrong? Let's look at it when we have it up. Okay, it's this guy right here. Seems to be a failure of the, well, are we converting it to spans correctly, I wonder? Token start is the token start line. So that'll be 2 and 0 and 2 and 3. Right, so those should go in that way. So what were we doing with them here then? Spans. Oh shit, maybe it was my contains code that was dumb. Let's see. Our physical line is the line index, and start a visual line plus I. So what was in that case? It was 2, 0. That should be where we start. Let's see, debug. Looking for physical in span span dot start dot line spans and span start column. Okay, let's just do that. This will be very, very noisy. Oh, it's entirely too noisy. Let's see. I guess, well, we know that it's only physical line 2 that we're interested in, so we could say physical line is 2. We'll say no, or yes, color to string. Oh, and actually, we also only want to show these. Very fancy debugging here. We're going to see why this is going wrong. Okay. Span from 0, 0, that's that first one. 0, 18, that's the white space. Wait, what? So 2, 0 is in the span that starts here. Crap. Okay, so that's because the white space starts here and goes here. So this is not, this doesn't seem correct. Right, yeah, right. This is the problem, that every token ends on a character and then the next one begins on that same character. So that's not right. Okay, then we know what the problem is, then we can just fix it. Fix me. This is horribly inefficient. So where was the lexer? So we are producing all of these tokens. Emit token. So the single character tokens, they're good because they have the 1 position. And then the start position here, I guess what we want to do is when we're committing, then we've already consumed, so we want to have the previous position. So the token is going to end on the previous position, like last position. Say previous. Previous? Yeah, previous. It's not trivial to compute it, so we're just going to have to keep tracking it because, because of the new lines, then we have to keep track of what the previous position was. So up here in consume, we'll just say m previous position is m position. Okay. Wait, how did we do emit actually? Emit token uses the position. Wait, emit token uses the position, but we have to, in that case, we can't rely on consume to update previous position. Emit token. Start is m position, end is m position. But this does not It doesn't advance end position, does it? Only consume does. And these don't consume, so that's an issue. So emit token needs to consume. So I guess we'll just do that here. And look at that. Isn't it just beautiful? So we have our preprocessor stuff here in the purple. We have our keywords in the green. And we got our identifiers in blue. Numbers in blue also, incidentally. But that's pretty cool. That's a good start, I think. Pretty happy with it. So let's just do a sanity check that text editor still works if you don't have this spans. And yeah, that's really, really freaking cool. Of course, this is going to fall apart if you give it a file that has a bunch of tokens that we don't know how to lex yet. But I think the general approach here is pretty sane. It allows us to do basic syntax highlighting without having to bring in something complicated like Clang or something like that. And I think this will be something that we can build on and improve and keep going forward with. So I'm going to commit some stuff. Let's do the text editor first. So here we render them. If we have span information, then we draw them. We draw the text character by character so that we can pick up the color from the spans. It's definitely a fix me that we should do this in some more efficient way, but this was just about doing a first implementation. What's going on here? I don't want these changes. Text editor. I mean, sure, we can do them in a separate commit or something, but I don't want to murk up my patch with that. Oh, I gotta add. Okay, and then span. We could refactor span to be a range. We can do that in a following patch here. But basically, yeah, so the mechanism is that you have these spans that just have a start and an end, and then the spans have fonts and color, although the font we ignore right now, but I guess we can not ignore it eventually. And then you can set a bunch of spans on GText editor, and then it will respect that when painting it. So in order to make this work, we're going to, of course, have to update these spans and like lex as we go. So we're going to have to like relex. And you know, there are definitely ways to be smart about that. So, but I think we'll probably start by doing a naive solution and then iterate on it, because I find that that's just the best way to make rapid progress. You gotta be willing to be naive. So gtext editor, add a spans mechanism, or just a span mechanism for having ranges, custom styled ranges, text ranges, custom style text ranges. Yeah. It's now possible to give gtext editor a vector of span objects. These spans currently determine our spans currently tell the editor which color to use for each character in the span. The idea is to, there's also a font. Okay, what? I don't know why I keep making excuses for the font member. This can, I'm just going to remove the font member and then we'll bring it back when we need it. This can be used to implement basic syntax highlighting. Okay, and then let's remove that font thing because I don't want to be making excuses for it. Okay, and oh shit, did I feel like I was assigning to it here? Yeah, but it's just null footer. Okay. Then, of course, we had a bunch of improvements to the lexer that we can do separately. Lexer now works with positions and instead of indices. So Studio make CPP lexer work in terms tokens. CPP tokens have line column positions. These are infinitely more useful than raw indices into the input text, and can be used to implement, we don't have to keep saying that it can be used to implement syntax highlighting. Oh, and then now we can remove that blob here. So that's just for the initial testing. Okay, so these colors here are not the best, but I'm just gonna put them in for now. I think we'll probably, let's keep this debug output for now so that we can see what we're working with. But basically, yeah, so if we open a file name that ends in CPP, we'll run it through the CPP lexer and then create spans, colorizing by token type. And that's it. We'll set those spans on the text editor and boom. Okay. Hack Studio. Lex CPP files and apply syntax highlighting based on token per token. Apply some basic syntax highlighting. Yeah, that's okay. So, when we open a file that ends in CPP, whose name ends in CPP, we now pass the contents through CPP lexer, which produces a CPP token stream. Those CPP tokens are then converted into gtext editor spans and handed over to gtext editor, which then colorizes the source code accordingly. This is pretty neat. Awesome. So let's see that one more time. Okay. So obviously this will not work correctly if I start typing here. You can see that the red ends over here because we're not updating the span information on text change. But it's a start. Obviously, we're going to have to make it reactive and automatically updating, and then we're going to have to tweak the colors and all kinds of things. But I think I got to where I wanted to for this video. So this is going to be the end of it for today. So if you made it this far, then I thank you for watching and hanging out. I hope everyone enjoys the DevTools hacking series as much as I enjoy making them, because this is really fun. I did not have any idea how this was going to turn out, and I'm really pleased with the results so far. I hope you saw some interesting stuff, and yeah, thanks everyone for hanging out. That's great. I'll see you next time. Bye.